Welcome, ladies and gentlemen, to your MN29 notes. This is the first note guide of Chapter 6, which is where we're going to use ratios and proportions to solve all sorts of geometry problems. In this section, 6.1, we're going to use ratio, proportion, and the geometric mean, or we're going to focus on those three concepts. You can reference this in your textbook on page 356 to 359 if you need a little bit more information than what I'm showing you in this note guide. Example 1 in your note guide, it says you want to paint a mural on a rectangular wall. The perimeter is 484 feet. The ratio of its lengths, the length and its width is 9 to 2. Find the area of the wall. Now I'm going to first of all take a step back and make sure you're understanding what the word ratio means. When you say 9 to 2, that means for every length that's 9, the width is going to be 2. So if the length is 18, the width would be 4. Or if the length is 27, the width would be 6. So this is the 9 to 2 means that is the ratio of those side lengths. Another way to write a ratio is you can write it out 9 to 2 or 9 to 2. So ratios can be written a number of different ways. I'm going to erase that just because there's not a lot of space in this, but I wanted to kind of take a step back and make sure you remember that a ratio is really just a fraction or a factor, in this case, of a length and a width. So if that's the case, then this length right here is going to be some factor of 9. So I'm going to say it's 9x because we don't know if it's, 9 times 1, 9 times 2, 9 times 3. We don't know which factor or how large the length is. We just know it's going to be a factor of 9. As well as we know that this width is going to be 2x. Typically I say length is the long side, width is the short side. So if this is 9x up here, 2x over here, that means down here, this is also 9x. And this is 2x. So when we're talking about a perimeter, now again, kind of I hate to say take a step back again, but we're finding the area of the wall. That's the whole purpose of this problem. We want to find the area of the wall. And we can't find the area of the wall unless we know the dimensions. The only way you can find the dimensions is by creating an equation to solve for x. And in this case, they're giving us some information about the perimeter, which is that it's 484 feet around this mural. So we know that one of the lengths is 9x plus the 2x. Remember perimeter is always just going right around, and we're going to set that equal to the perimeter they give us, which is 484 feet. So we have 9x plus 2x plus 9x plus 2x, or you could, of course, go 9x times 2 plus 2x times 2, because there's 2 lengths of 9x and 2 lengths of 2x. We're just going to kind of keep it simple here, 484. So this right here is the perimeter, and then on the left side is how you actually calculate perimeter, which is to find the length around or distance around a shape. In this case, it's a rectangle. I add over here, I combine my like terms. This is going to give me 22x equals 484. I divide out by 22 to solve for x. And my unknown variable is 22. Took me for a moment to think about that. So this right here is an important value because what that's going to do is tell us or help us calculate the length and width of the actual triangle or triangle. Oof, we've been studying triangles so much I'm going to say triangles. So I'm going to put 22, this 22 right in for 9, or not for 9, for x right here. So 9 times 22, so 9 times 22 means that this length right here is really 198 feet. So that's what that length is right there. And if I go 2 times the 22, and remember, x is just a variable, the unknown. We didn't know what it was. We found it because we knew that this length and width has some factor of 9 and 2. And this is going to be 44 feet. So the length of the rectangle is 198 feet. So this right here is 198 feet. And this right here is 44 feet. So to find the area, I'm going to come right over here. It's going to be length times width, or base times height. My length is 198 feet. My width is 44 feet. When you multiply those two together, you're going to get an area of 8,712 feet squared, because we're talking about the amount of squares, feet, that fit within that mural. So right here where it says solution sentence, this is where I'd expect you to write out your solution, where you would say something like this. The area of the mural is 8,712 feet squared. Okay. So again, when you're given a ratio of side lengths, really the best thing to do would be to draw a picture and set it up very similar to what I just did. And we're going to do another example down here in example 2, just to make sure that you're really seeing what's happening here. It says the perimeter of a room is 48 feet and the ratio of its length to its side is 7 to 5. Find the length and width of the room. So this is what we're trying to find here. Always remember, at the very end usually is what it's asking you to do. I'm going to have you pause this video and actually do this very much like we did example 1. So you're practicing it, seeing if you can figure this out, and then restart the video to see if what you have and I have correlate. I'll talk to you soon. Welcome back. As you can see, I found that the length, excuse me, if this side ratio, or the side ratios are 7x to 5x, and I found that my x value is 2, by using the same method as I did in example 1, I can now take this 2 and put it in for x to find my actual length of my rectangle, which in this case would be 14 feet. I wasn't sure what the units were. And then over here, 5 times 2 is going to give me a width of 10 feet. So the solution sentence should be something like the dimension of the room is 14 feet by 10 feet. Okay, so there's just giving you another example of what we had done in example 1. And notice key to that though really is making sure you draw your diagram. Example number 3, you need to estimate the number of trees in a 150-acre area. You count 270 trees in 2 acres. Assume the trees are evenly distributed. Estimate the total number of trees. This is very typical of any kind of sampling. We're not going to want to take 150 acres and actually count all the trees. That would be ridiculous. So we use proportional reasoning. Proportions are just where you have, or is, where you have a ratio set equal to another ratio. So for instance, here we have a ratio, 270 trees in 2 acres. So I'm going to write that ratio down, and I usually typically write ratios as a fraction. So 270 trees per 2 acres. Notice a couple things, folks. I have it as a fraction, but more importantly, I have my units, because units with proportional reasoning is essential to know what the heck you're doing, or how you're setting it up, or that you're setting it up properly. The reason I say that is here's one ratio over here. This other ratio on the other side, to create a proportion, is going to have units directly across that should be the same. And if they're not, you haven't set it up properly, at least in this way I'm setting this one up. So if you have 270 trees in 2 acres and you want to know how many trees in 150 acres, so you're going to put 150 not in the top where it's trees, you would want to put 150 down here where it says acres. And this is where you can use any kind of variable. I'm going to use a t for trees. And I'm going to solve this. Now I'm going to bring this over here so you can see it a little bit clearer. So 270 over 2 equals t over 150. Now that we know that we have it set up properly, I'm going to drop those variable or the labels. I'm going to cross multiply here. So 270 times okay, when we multiply those two together, we get 270 times 150 is 40,500. I had to go grab my calculator really quick because that was something I couldn't do in my head really quick. 2 times t is going to give me 2t. So this is just like that worksheet we just reviewed, solving proportions. We divide out by 2. We get that the number of trees is 20 1,250 trees. Right there. Okay, so that's, I'm sure you've seen that kind of problem before, but I wanted to just kind of recap that, or review it, I should say. The geometric mean, there's something you've not heard about, or actually you've probably never heard the word or the phrase geometric mean, but it's something you technically use a lot when you're using proportional reasoning. But let me just define geometric mean. I'm going to switch colors here to blue. If you have a over x, I'm going to give you a very, very general form. A over x equals x over b. And if you cross multiply this, you end up with a b, so a times b here, cross multiply, equals x times x, which is x squared. And if you want to solve for x, you would take the square root of it, and you would end up with the square root of a b. Now that doesn't mean a whole heck of a lot, so let me kind of show you how this works in example number 4. It says find the geometric mean of 12 and 27. So we're going to use this form right up above in my definition, so I'm going to go 12 over x equals x over 27. And this is where you're going to cross multiply, and I'm going to bring this down here just for more space. So 12 times 27 is going to be 324. X times x is x squared. You take the square root of both sides of that equation. And since the geometric mean can only be positive, the square root of 324 is going to give you 18. We don't need to think about the negatives at all. So the geometric mean is different than the arithmetic mean, which is where you add them together and divide by however many you're adding together. This is different. This is using proportions. And we're going to be using this a lot as we go through the chapter, but the first thing I need to just do is teach you the skill of what a geometric mean is. So this is how you're doing it, very generic, but we'll get more into it in the next section. Thank you for tuning in. You'll see the homework on the bottom, and if I'm not mistaken, we have an edit. It should be 18 through 24, not through 21. So page 360, 11, 12, 18 through 24, 30 through 33, 57, and 60, kind of a smorgasbord of problems. Thanks for tuning in.